going in, what data is coming out, and if we need to tweak anything, then we know what we need to tweak. And we'll also look at the over 300 connectors that are available in Power Automate for me to connect out to a massive wealth of different services, not just Microsoft, but all sorts of providers, including the likes of Google as well. So I'm not a fan of PowerPoint, so I'm going to stop my PowerPoint presentation there. And we're actually going to go and have a look at Power Automate. So let's drag it across. So Power Automate is very, very simple to access. So starting from the very basics, if I've been using it, it's on my app launcher, it's available from my Office 365 portal, or it's available from flow.microsoft.com. So when I talk about flows, Flow was the old name of Power Automate, but in Power Automate, we still create flows. So great naming conventions around the way that we use it. So if you do hear me talk, say flow, then I'm talking about the automations that we're about to produce. And there's a number of ways that I can get started with Power Automate. I can start from templates. There's a huge number of templates that are available there for me to get started if you've never used this before. And just to really quickly show you one, let's just go and get today's weather forecast. I can go and select a template. I can create a flow, and it will then go away and it will provision everything for me. So like I said, these are very just really for getting you used to the actual interface and the sorts of things that you could potentially do. And just to run this, just to show you the actual debugging side so you can see what we're going to be doing later, I can always test these flows. I can perform the actions, I can save them, test them, and then I can actually watch it run. Or I would if I'd actually selected one where I've got location services enabled. We'll see more of that later. Hey ho, it's a live demo. Things go wrong. So let's go back to the flows for a moment. And let's go back to create. So yes, there's a lot of templates, but to be honest, most of those probably aren't going to be exactly what you want. But there are additional things in here that might be. So I can, if I'm interacting with various services in Office 365, so for example, if I'm writing code and I'm feeding that into SharePoint, then I can use SharePoint as a trigger to start my automations. I can use instant flows, and we'll see those in a moment, or I can even use this to create my scheduled tasks. So rather than writing some code and pushing that into maybe an Azure function, which is running on a timer, or an Azure automation, then I can schedule it here. But let's go and create an instant flow. And I'm just going to skip that for a moment because I want to get straight into the editor. So this is the editor that we see when we're talking about flow. And what we're talking about when we actually talk about triggers and actions, they are all wrapped in what are called connectors. Connectors are designed to be a wrapped up web service or a number of web services all wrapped up under a specific umbrella. So for example, if I was wanting to interact with Exchange, then I have an Office 365 connector that allows me to connect to Office 365 without having to worry about the underlying web service calls and be able to use that in my automations. So each of these that we see at the top, and I'm just going to expand this, are all the different connectors that we have available to actually work with. So I've got FTP, I've got SAPs in there, I've got Stripe, I've got Twitter. There's a huge number. In fact, there's over 300 services that I can now connect to within Power Automate. But if I come at this really from a very basic point of view, I'm just going to go and create one with a flow button to start off with. So this is a manual trigger that I'm just going to press something on the screen and it's going to run. I can then build up my logic by just pressing add actions, and then I can start to select a service that I want to interact with and potentially go away and do something. So for example, I use the example just of Office 365. So I'm going to go for Office 365 Exchange, Office 365 Outlook. And if I want to send an email, then I can select my send an email. I can give it a to, I can give it a subject, I can give it a body. So let's do that. I can save that. And this time I know for a fact that when I run this, it's going to work. So let's just go and run that, and let's just see what happens here. So I'll run the flow. It says it's run successfully, and then I can actually look at the debugger. So I can see here that this one was successful. I can see what was going in, which for the because of this trigger, it wasn't much. But I can also see what went into this web service call. So this was a web service call to Exchange to send an email that has then gone away and done something for me. And I can see here, these were the inputs, the to address, the subject, the body, and it would have generated an email, which is what the output is, and it would have sent it. So the whole idea behind that is that is allowing no coders to do exactly what you guys do and what I used to do as a developer, to actually write those functions to send those emails, but it's doing it without actually having to look behind the scenes at what's going on. So that's very much a no-code approach. Let's go and have a look at how, let's just delete these, how we might actually use this within a development context. So if we think about what we do as developers, we pull together the requirements of a user. The users will have given us what they consider the process to be. We might have then developed something that we want, that we think they want. And there's a lot of back and forth really about trying to get everything right. But also, it might be that I want to create something and I want to use all of these connectors and all of this power that I've got in Power Automate without actually having to write all this myself. And what we can actually do here is I can use a different sort of trigger. And I can use a HTTP trigger. So I can use this, which is when a HTTP request is received. Now, like I said, this is premium. So I pay £15 a month to get all of these premium features. But I can use this, and what that will do is generate a REST endpoint for me to hit. So whilst I'm away coding, I can be doing all of that complex development that I normally do behind the scenes, because it might be that I can't do that in any other tool. But then there's no reason why I can't fire something up against this endpoint and then do something in Power Automate as well. So I'm just going to come into here and I'm going to start to build out something that I might want to do. Now I'm going to use an interaction with SharePoint as an example. So if I was to do this via my own code, I would have to get a bearer token to then authenticate a REST call against SharePoint, go and then call the REST API for a specific list or a library to get some information, to then return that, and then for me to process it. So I'm going to try and work through that scenario, but by using Power Automate. And then we're going to see how I can then use this from within my developments. So I've already said that I want to connect to SharePoint. So I'm going to use SharePoint here. And I'm going to select the SharePoint connector. And then I've got a number of actions. So these are all pre-canned HTTP requests I can come and select. So I don't have to worry about actually writing these myself. If I want to, I can call additional HTTP requests. But I'm just going to go and I'm going to get some items. And then I can visually configure my HTTP request or my action by actually just filling in the form. So if I come into here and I'm going to go and select something from my user group management site, I'm going to go and grab something from my info list. And what I'm going to do is just have a quick look at my user group list. So this is where I'm trying to get information from. And I'm going to go and select where this row, where the title is equal to the Black Country Power Apps and Power Automate user group. So far, everything that we've done is very much no code. Where your benefits as a developer comes in is where we start looking at these slightly more advanced features like filters, because I'm actually now building up more of the REST query, the query string. So I'm going to say where the title is equal to, and I'm going to give it something in there. So I'm telling it to go and find something where the title is equal to Black Country Power Apps and Power Automate user group. So that is going to get some items back for me. So let's go and just test that. So that's going to run. Actually, what I needed to do first was actually grab the address. So one thing I should have pointed out when I hit save is that it generates the HTTP endpoint for me. So I'm going to copy that for a moment. Let's just go and fire up Notepad and just show you what's actually been created. So this is what's actually been created. So it's given me a HTTP endpoint. It's given me an API version. It's given me a number of parameters that need to be associated with that. So if I need to trigger this, I'm going to go and run Postman up for a moment. So I'm going to come and grab Postman. I'm going to actually then hit that endpoint. Let's just post this, put my address in there, and I'm going to send it. So I'm now really simulating me actually calling that endpoint from my own code. So I've got my 202, it's been accepted. So it's been accepted for processing. And if I come back and just look at what's happened, it's succeeded. I can see that my HTTP request was received, and it's then gone and queried SharePoint, and it's got some information back for me. Let's go and add some more stuff. So what I can do in here, as well as having just one step after another, is I can have conditions. So I can build conditional logic in here, but I can also have parallel processing. So I can have two different streams of logic taking place in one go. So I can have multiple threads firing out at different times asynchronously without having to, again, control that through my own code. But what I'm going to do is I'm just going to come and grab, I'm just going to put a compose action on here. So compose is an equivalent of a stateless variable. So it has no, a typeless variable. It has no type. I can just throw some information in there, and it's going to have get some information back. And let's go and select some information from there. So let's go and select something. Let's go for refreshments. So what that's done is created a loop, because what I'm actually getting back from getItems is an array. And then so what Power Automate is trying to do for me, because remember this is at the moment aimed at no coders, is to allow us to be able to handle that array. It's going to loop through it. But as a coder, I don't actually want that, because I only want the one item that's coming back. So this is where your skills as a developer come in again, because I can not only just use dynamic content, which is what I'm able to select from the actions, I can also use expressions. So I'm going to come up here and just use another compose. And hopefully some of this should look fairly familiar. So if I come into here and I can use my expressions, and I can use my expression editor, and I can say first. So I have a number of functions, exactly like what we use when we're developing, to actually pick the first item from an array. And from there, I could say I'm actually going to take the first item that came from my getItems. So I'm going to take the body that came back from getItems. So apologies, I am whizzing through this because there's so many cool things that I really want to show you to actually go for this. I'm going to select what actually comes back from the value. And then I'm going to select what I want from refreshments. So if I think back, the way that JSON normally comes back is that I would have to go and select the value from the values array, and then I would select what I wanted from there. Actually, that's not going to work. I need to put that on the outside. So basically, that's going to take the first item that it gets back from the array and just show me what's in the refreshments. So let's get rid of that one, because I don't want that. But now that I've actually run the test once, and I've triggered my flow once, I can come and actually re-trigger it again using that same information. So let's go and save and test it from within Power Automate. Okay, and this time it's got some information back, and I've got something that I can then use. So there's a huge number of expressions that I can use to do this data transformation as we also go through our automations. But so far, yes, this is working quite well as almost a debugging tool. So I can see what's coming out of, for some reason it's not showing me my outputs, but I would normally be able to see what's coming out of getItems. I can then see how my data interactions are working. But you know what, let's actually complete this. So let's actually go and return something back to my original call. Because as well as having this triggered from a HTTP request, I can also return something back to the originating call. So if I go and look for response, I can post something straight back. So I'm going to give this a 202, and I'm going to give this a body of refreshments, and I'm just going to use my outputs. So my output came from compose 2. So whatever I got in this field will be output here. So really, that has now given me what I would normally expect from making a REST call to something that I write, where I receive a request, I do some processing on something, and then I'm going to return a value back out. Let's go and save that. And I'm going to go and perform the trigger action this time, because what I want to do is go back to Postman and run this again. So let's go and send that. So I can see here that I've got my response back to my web service request. But it's taken me seconds to actually build that in Power Automate, and it's been built in a visual way. So it's very, very quick for me to be able to build those interactions, build that processing, but I can still then leverage it through my own, through my other developments. But the final thing that I can do before I really close off on this part is that, as well as having just a normal request going in, I can also build a JSON schema here to actually say, what do I want to receive as part of my request body? And I don't know about the rest of you. Certainly when I was writing web service endpoints, I hated writing JSON schemas. So I'm going to use Power Automate to actually do this for me. So I can actually go and tell it to create paste a sample in here, and it will create that JSON schema for me. So I'm going to go and say, let's call this field. And this is my example, is that it's going to receive refreshments in the body, or something called fields, but refreshments is a possible option. So if I click done on that, then it will create the JSON body, which means I now get some validation coming through what's coming through my my request. But now that I've done that, I can also now use this the field that comes in. So sorry, the property that comes in. I can use that in any of my other actions that that are in here. So rather than in my options here, in my compose, saying that I want to select. Oops, didn't mean to do that. Let's go and select this. And you're not going to show me my expression. Ah, there we go. So rather than having here where it says refreshments and that's hard coded, what I could actually do here is type in a reference to my trigger. So I can actually use that further down. So if I say that in my trigger body, I'm going to go and get field. So let's grab that and let's update that. Let's make sure that's saved. No. That's better. Okay. So now I should see that the field that I pass in as part of my web service call will be used in my compose so that I get the relevant information back from the response. So let's go and hit save. Let's go and hit test. Just wait for that to go into test mode. Okay, cool. Back to Postman. So let's come back up to my post. I'm going to supply a body to this. He says, let's go and create a new one. Where's my body? The request doesn't have a body. That's because I'm using a post rather than get. Let's go to raw. Actually, is that going to allow me to do it? Yeah, perfect. Okay, so let's come back to here, and what I'm going to provide is field, and let's go for a different field this time. Let's go for cancellations. So I'm going to just, because we saw refreshments come through before, I just want to show that I'm not hard coding any of this. So let's go and select cancellations. And let's go and send that. Field mismatch, okay. Okay, what are you expecting an object? Okay, let's try this once more. Okay, one more try. No, okay. For some reason, it's not a
do you need to change the content type to JSON?
Yes, you're right. Thank you.
There we go. That was from Lee, in fact, in the chat. Thank you, Lee.
Thanks, Lee. Okay, perfect. Well spotted. Thank you for that. So there we go. So this time it's passed field in as cancellations, and it's actually, yes, I've returned refreshments as the field type, but hey ho. But it's actually pulled back my what I'm actually looking for, which is the cancellation text that came from SharePoint. So the whole point of that was really just to illustrate that you can use Power Automate as a way of offloading some of that code that you would normally have to write by hand. That you can build all of this up visually, and you can do it in such quick time that you can really achieve a lot. But where we look at no code and pro code uniting around this is the fact that while as pro coders you are able to do your all that really cool stuff that you do in terms of the interactions, in terms of the interfaces and so on, you can actually hand some of this across to maybe someone who's not as technical, whether that's a process manager or even the process owner, to actually come and create the processes that they want in Power Automate, and then you can hook into that so that, number one, you know that the process is correct because the process owner has actually mapped it all through. And it just allows you to offload some of that work between you so that you are working together to get to an end result. So that's just a very quick introduction to how you could potentially use an automation and Power Automate for doing some of what you would normally do by writing lots and lots of code. Are there any questions on that before I move on? Was there anything else in chat? Is that a question or is that a background noise? Sorry. Okay, well, we'll take that as background noise. Okay, so if you do have more questions, then we can answer those later as well. So what I'm going to do is just quickly go back to my presentation for a moment. And so look at now what alternative ways that we can utilize our development within Power Automate. So what I'm going to really show is we've already talked about connectors and the fact that they are web services behind the scenes that you can then hook into and use and hook out to all these other applications. But what we're now going to investigate is coming the opposite way. So we all write some really cool things, and it's about how we can also leverage that within Power Automate and even Logic Apps to allow others to use our development. So we can surface our code to lots of other people within our organizations or to our different customers, and actually look at ways that you can really make your developments available to everybody in the world if you wanted to. Because what we're going to go through now is how we create a custom connector. How we're going to look at the wizard-based approach again, how you can do all this through the user interface, how it builds a Swagger file, how it builds the API definition behind the scenes, and then we'll talk a little bit later on about how you can get that certified so you can then get that published out to the Power Automate, Power Apps, and Logic Apps. So let's see the connectors. Okay, so I'm still going to be working here within the context of Power Automate. And on the left-hand side, I've got a number of different things that I can do. So I can look at my data options, and I can look at entities if I'm using the common data service, so the inbuilt database. I can look at any connections that I built, but I can also look at custom connectors. So that's what I'm going to do now. Before I get too deep into that, I'm going to just really introduce that I have a small bit of development, well, not necessarily development, but I've got a Logic app in Azure that sits behind the scenes that has the same sort of pattern as what I've just seen with Power Automate. So I've got a HTTP request trigger. It's taking in a couple of integers. It's doing nothing difficult. It's just multiplying two numbers together, and then it's going to return it. So this is only really one step beyond Hello World in terms of the functionality that we're looking at here. But this same approach that we're about to go through could be applied to something that you create and you deploy to Azure Functions. It could be that you've got your own web service sat out there on your own servers or in your own hosting environment that you want to be able to connect into. And this is how we'd be able to do it. So I'm just going to first of all grab that HTTP URL. And I'm just going to bring that into Notepad for a moment. So custom connectors are really designed for you as developers. They're not necessarily designed for no coders, because we're now starting to talk about how we interact with web services. We're talking about how building up JSON bodies, looking at authentication, lots and lots of things that really go beyond what an end user would do. But there's no reason why you can't leverage what you're doing and giving it to the end users by using a custom connector. So when I click on New Custom Connector, there's a number of things that I can do. I can create one from blank, and that's what I'm going to do in a moment. I can use a direct connection to an Azure service. So if I'm using Azure Functions, then I can point this straight, or even an API which is hosted elsewhere in Azure, I can point it straight to Azure and it will figure everything out for me. If I want to write an open API file or consume one, then I can import one. And I can also do all of this within Postman. So I can use Postman to create a collection, pull everything together, and then I can import that as well. But I'm going to go and create one from blank just to show you everything that actually that you can potentially configure. So let's call this .NET Knots, and I'm going to hit continue. It starts off really just by giving it some basic branding information. So I'm not going to worry too much about that. But what I am interested in is down here, which is where it's talking about the host and the base URL. So it's talking about the base identifying parts of the URL that I'm going to use to connect to my web service. So if I come and grab this, I'm just going to go and grab my UK West address, and I'm going to put that into my host. My base URL will be workflows, because that's the static part. The rest of it can change. And let's click next. So I'm going to be driven through a wizard here. So we've done the general stuff about this is just the base API. How do I want to secure my API? And there's support here for a massive, for all of the common sorts of authentication types that you might want to use, whether it's no authentication, whether you're just using basic usernames and passwords, API keys, or even if you want to use OAuth. So you've got OAuth 2 as your provider, and you can actually then select a number of OAuth providers to use as your data source. So whether that's Azure AD, Google, whatever it is that you want to use, you can authenticate directly using those. So what you would do is provide your client IDs, your client secrets, and the various URLs to generate the authorization token, and then you can use that to then to control access to your API. I'm just going to switch this back to no authentication to keep this simple. And then if I click next, then this is where I can actually start to create a number of definitions. And the definitions break down into two real areas, actions and triggers. So these are two things that we've already spoken about very quickly when we looked at Power Automate from the user point of view. So a trigger is something that is going to start a process. An action is where we actually build our logic. So I'm really going to focus on the actions part. And at the moment, I have no actions here. So I'm going to go and add a new action. And I can give it some basic information that I want in here. So I'm just going to call this demo data. I can give it a description and I can give it an operation ID. So the difference between the summary and the operation ID is if I'm using this programmatically, demo data, the operation ID is what I would actually be referencing. If I'm using Power Automate and therefore I'm using the end user point of interface, then that is what they will see. So user-friendly developer.
Matt?
Yeah.
Timothy Speet is asking, what about the JWST bearer?
This is where my development skills are out of date. So let's go and have a look. So theoretically, as long as you can generate a bearer token, then you should be able to use it regardless of how you pass it. Forgive me, is that normally an OAuth token?
Let me see if I can find Timothy in the chat. There he is. Did you want to ask directly there, Timothy? I've unmuted your mic.
How are you feeling?
I think it works in the OAuth screen. Just reading the chat. Don't know. Did you want to get more into that at the break and ask a few more questions at that point, and then we'll carry on?
Okay.
Okay. Cool.
Okay. In the meantime, I'll quickly I'll dual action here. I'll be googling those tokens as well. So back to the action then. So when we build the actions, effectively what we're doing is providing the endpoint that we want to hit. So I've got that already here on my notepad. So this is what I'm targeting within Azure. So like I say, I'm targeting a logic app. This could quite easily be the endpoint for an Azure function. And I can build my request here by importing it from a sample. So my sample is effectively what I've just got on my clipboard, because that's everything that I need to provide. That's the actual URL. It's all the query string parameters. It's everything that gets included in that URL. So I'm going to post that into my URL field here, because it's quite nice the way that this all pops out to actually just guide me through each step. So I can provide it with a URL. That's going to pull out, as we'll see in a moment. Oops. That's going to pull out all of the query string parameters that are attached here. So my SV, my signature, and so on. Let's go and repost that. But I can also build here, again, a body. So I can supply it with an example of JSON that I actually want to pass along with it to actually help build my query as well. So I've got that on another clipboard. So what I'm going to do is I'm just going to take two numbers, number 1 and number 2, and I'm going to import all of that. And so what it does actually creates the request in here for me. So I've got my demo data. Here's my request. And what it's actually done is break out my query string parameters into individual objects that I can then interact with. And it also breaks open my body. So then I can actually go and set some more rules around what I want in terms of what I want people to enter for the body values. So for example, if I come into my API version here, now this is again is where you can potentially make your users or whoever's consuming this, their life that little bit easier, because the API version, I want that to be quite static. I don't want my end users to be messing with that, because that's break territory. But what I can do is I can give it a default value. So let's come and let's just break this down. So here's my API version. Here's my SP value, my permissions, and my signature. So I'm going to go and grab my API version, and I'm going to drop that into my default value. I can say, yes, this is required, because if I don't provide a value for this, then it's going to break. But I'm also going to hide this from my end users, because I don't want them to see this at all. So I can make this internal. I can also make it important, which means that it has to be, which means it will always be visible when users try and interact with this. Or I can make it an advanced option, so it appears in a drop-down if they select the advanced options. But I'm going to need to hide it, so I'm just going to make it internal. I'm going to supply some validation around it, so it's a string. Do I need to supply a format? No, because it's just a standard string. So I can set some rules around this. So I'm going to very quickly fly through the others and just fix those as well. So let's go and SP, is it required? Let's go and drop that into my default value, get rid of my encoding. That's internal. I can do the same with the SV, but for some reason it's turned out to be an integer and I want it to be a string. One little thing, if you do ever do this for a logic app, always make sure that your the SV parameter is set to a string and it goes to as 1.0, because 1.0 means that you can interact with it. That's your permission value. It's bitten me quite a few times. So that's that one done. And the final one, what is the signature? That lovely random value. Yes, it's required and it's internal. Okay, I just spotted that my SV hasn't updated right. Yes, it's required and it's internal. Cool. Okay, so now everything that's in my effectively my query string is hidden from the end users. What I am interested in doing that, providing though, is the values for the body. So if I go and click edit here, I've got number 1 and number 2. So this is what I provided when I put in my sample. And if I want to, I can give it a friendly title. I can give it a default value. I'm going to make this required again, but I'm not going to change anything else here. I'm going to leave it as an integer. So let's make number 2 required as well. So now I've set the rules around how people are going to interact with my my REST endpoint. I'm going to go and create the connector now, because default value is string. Right, I'm just going to double check that. And I suspect it's that one. No, that's a string. The joys of on-the-fly debugging. Integer. Integer. So try once more. So okay, it's playing silly. So let's go edit. I'm just going to change that back to integer because I think that's probably what it's complaining about. Yeah. Okay, so what I'll do is I'll actually modify that in a moment and we'll fix that. But what I can do is, now that I've built up the interaction for my endpoint, is that I could go to test and then actually run it from here. But I know at the moment this is going to fail because, like I've said, the SV wants this to be 1.0, but it's complaining it wants to put it through as an integer. But what I'm going to do before I actually run any of this is just close out of this. Actually, no, I won't close. I'll go to my Swagger editor, because what I've done visually through all of that is actually create my Swagger file. I've created my whole API definition, again, without me having to worry about doing all of this myself. All I've done is taken what I'm expecting. I've provided a URL, put all those into the various boxes, and it's done all of this for me. But if I want to then go away and do something else with that, then I can take that out of here. So I can close this. I can come and look at my .NET Nots and I can download it. I can then open it. We can do some additional. Sorry,
Richard suggested maybe your default needed quotes.
It will keep stripping it. It's an issue actually at the moment with the way that it takes all these at the moment. So it's a bit of a pain. But at least it's going to allow me to just show you how we can modify our JSON field or our JSON API file. I can change that to 1.0. And let's save that. Because what I can do then is I can also then re-import, or I can import updates across the top of this. So I can import this time from an API file. This just shows the other way of doing it. Just go and grab that from my downloads. That will just pull everything back in, and hopefully this time, if I get to test it, let's just run a quick update. Perfect. Okay, so this time it's going to accept it as a string, and then let's try and run it. So let's go for a really complex operation. So let's go for that. Oh, I need to create a connection first. Let's test it. I get a response, and I can see what body comes back. So what I've done now by creating this is basically provide a user-friendly, a no-code friendly method to come and interact with everything that I write. So let's go and see where I can now use that. So I'm happy that I'm getting that result back. Let's go and create another quick flow. I'm going to go and create an instant one from a flow trigger again, just to keep it nice and simple. Let's go and add a new step again, but this time, rather than selecting one of the existing ones, I'm going to go and select my custom connector. Here's my .NET knots, so I can use that. Notice it's not asking me for any of the additional things that I've configured in the actual connector creator. So it's not asking me for any of those URL parameters. It's only asking me for number 1 and number 2. So let's go for 6 times 10. And let's just quickly test that. Okay, cool. So it successfully ran. And it's correctly multiplied number 1 by number 2, and so it's returned that. So you can. So the whole point of this is you create a number of interfaces that normally you would only really access maybe from 1 or 2 different endpoints, and they are endpoints that are very much in your control. But if you want people to start consuming your services from areas where they can control, whether that's within Power Apps, Power Automate, and various other locations, then you can create these connectors to allow people to start consuming all that good stuff that you do in a way that is really user-friendly and really starts to unleash the power of what the Power Platform can do. Now, that's very much being internal to the way that we create those interfaces, with the way that we create those connectors. If you have a service, then you can make that available for anybody in the world to be able to use in this same way. So you can go and you can create some functionality, you can create a custom connector to start off with, get all of that right, and then you can submit that to Microsoft for certification, so then everybody else can start to use it. The certification process is quite easy. You just need to submit the basic use case behind it. It will then go through some basic validation from Microsoft, and then quite quickly they will roll that out across the world. So I've gone through that process twice now in terms of getting my own connectors out into the Power Platform, so I know it is extremely simple. But it does mean that rather than just having a focused customer base, for example, in the UK or Europe, you now have the ability to bring everybody in the world in. Everybody in the world is now your customer, regardless of whether they are IT, whether they are actually a CTO or CIO, whatever it might be, or they're actually an end user. You actually have the ability to target your services out to everybody. So there we go. That's in an hour, really 2 key ways in which you can use Power Automate to help leverage what you do as in your development. Number 1, from the user point of view, being able to be able to create the flows that you can then call into. So rather than writing all the code yourselves, you can do it visually, you can debug it visually, you can use all of those connectors and all the authorization that takes place within Power Automate to handle all of that and just pass information back. And then we looked at the second way, which is where you can use connectors to write your own connector to create your own interfaces to your services that all of your users can then start to leverage. Are there any questions?
I've unmuted everybody, so you can feel free to unmute yourself and ask a question.
In silence. But hopefully what you've got away from that as well is not only knowing that you can do that, but how easy it is for you to do as well. It takes minutes to do that. And particularly if you're testing and debugging stuff, when I'm writing my code, this is where I would come. I will test my data flows. I will test my interactions with different web services. And it just saves me a lot of time and a lot of hassle.
Thank you very much, Matt.
Cool. Well, if you do have any questions, like I said earlier on, let's just go back to my social media slide again. Do reach out, do ask questions. I'm always more than happy to help anybody, just like anybody else in the community. So feel free to shout out and we can make sure that you get the help you need. And really thank you to everybody for listening to that for the last hour. Thanks, Pete, for allowing me to step in, and thank you to everybody for coming along and supporting the user group, even though we're in lockdown.
Yeah, thank you very much. Cool. So we'll switch across to Steve. Assuming he's not like dashed for the door.
Hold on, I just need to turn my video back on. I'm just trying to find where Zoom's disappeared. Okay. Right.
Yeah, that first talk was great, by the way.
Thank you.
Right. Okay. Can everyone see that?
Hold on, I'm just going to find you. Where are you, Steve?
On Death by PowerPoint.
Hold on. Hold on a minute. Why is it that I can't see you right at the very... Oh, there you are. I see you. Wait. Spotlight video. There we go.
Right.
Can everybody see that? Yeah, that's it. Cool. So I'm going to mute everybody again now. And I'm also then going to unmute Steve. There we go. Cool. So go ahead, Steve.
Right. Okay. Unlike Matt, who did a very demo-heavy one, I tried writing code samples for my talk and realised I'd be here for about 3 hours if I tried to walk through the code samples. So
hey,
you've got Death by PowerPoint instead, I'm afraid. Pete, does anyone need a break before I kick off? Or...
yeah, it's not a bad idea. If you do want a break, then do just go ahead and we'll get going in a minute or so to give you enough time. That's a good point, Steve. Good, thank you. So we'll get going at like 1 or 2 minutes past the hour.
Okay.
I've unmuted everybody again, just in case you do have any more questions there for Matt. If only you could hear the tumbleweeds.
There'll be a lot of that with the jokes in my presentation. So you just need a tumbleweed effect in the background, Pete. Just to let me know that people are still there.
Go on then, I'll ask a question. So it was about the OAuth stuff, because normally you see like JWST bearer sections and under like a security section within a like a Swagger file or an open API file as it's known now. So I was kind of wondering, so in your definitions, it just like had the token file and the path with the tokens directly in there. Does it go towards sort of like actually creating a whole security section and going down putting bearer in there?
So what it actually does, it will pass that it will generate the authorization token at the point that the action's fired. So it will then pass the token in through the header. So you can then use that in your own in what you're actually developing. So yeah, I mean, theoretically, you should be able to just set up that that authentication definition as you see fit, and as long as it will generates the token, then you should be able to carry that through as well.
All right, cool. I think everybody should have had enough time now to nip to the toilet. I'll mute everybody again. Mute you, Steve. There we go. So go ahead. Thank you very much.
Right, thanks, Pete. Right, thanks for everyone for listening. Thanks to Matt for his presentation. As I say, I have to walk through the examples. So what I'm going to try and do is get samples out there on GitHub or something over the next coming weeks, and then I'll put out something on Twitter to say when they're there. But so I'm afraid it is a bit of death by PowerPoint, but hopefully there's a few bits in there just to keep you awake. Hopefully this will work over Zoom, so let's go. As it's Star Wars Day, I couldn't resist but to have a Star Wars intro. Unfortunately, due to copyright, I can't really use the music, but if you all want to sing along, perhaps, Pete, you want to unmute everyone if everyone wants to start singing a Star Wars theme.
I'm not doing that.
So, in a garden shed somewhere in the United Kingdom. It is May the 4th day. So, Pete asked us, did we have a Star Wars joke? So, I will let the screen speak for itself. And I'm glad that it's on mute so that I won't hear your groans. So, why couldn't Darth Vader reach his chocolate? It was a galaxy far, far away. Boom, boom.
Yeah, I might just end yours now.
Yeah, okay. Yeah, but he managed to catch it, so right, okay. So enough of this frivolity. So the whole thing with this talk, as people might have heard me say earlier, originally this talk was going to be called Dependency Injection, the Booster Jab, with lots of medical imagery of people, doctors with syringes and what have you. And in the current climate, I thought that's probably not a great idea. So instead, I went back and had to think about, so this is effectively Dependency Injection, the greatest hits. So I went back to my album collection from 1983. Now that's what I call music. And looking at some of the dodgy haircuts there, anyone would think they'd been in a corona lockdown for 5 weeks with no sign of a hairdresser. And bonus points for anyone who can spot the Star Wars connection amongst the pictures on that screen. Anyone on chat or no? Okay, so up here in the top right hand corner is Lamal, who changed his name from his real name of Chris Hamill because he was fed up with people associating him with everyone. Mark Hamill. Right, okay, so with that in mind, I've taken the liberty of changing it to now that's what I call Dependency Injection. So, who am I? I'm Steve Collins. I've been developer for the last, 20 something years, certainly working with Microsoft technologies for the last 25 or so. I blog at stevetalkscode.co.uk and I tweet at stevetalkscode. So, with that in mind, there's an awful lot of dreadful song puns in the titles of these slides. So apologies to all the pop stars who may get offended if they ever saw this. So with that, let's kick off. Dependency injection, the basics. If you don't know this by now, well, this is all the sort of stuff that everyone kind of really knows about the Microsoft DI container. The DI container from Microsoft in .NET Core is a conforming container. So what does that mean? It's effectively does the bare minimum itself, but can act as an interface, gateway, facade, however you want to call it, to other containers. So it does the bare minimum that is the lowest common denominator between all the different container implementations out there, things like AutoFac and Ninject and all those. Out the box, it on the face of it, compared to those other containers, it doesn't do a huge amount. It supports constructor injection, but what it does do is if you put ASP.NET over the top, it also adds method parameter injection. So if you're an ASP.NET developer, what you may have seen is things like in your controllers, you can add a from services attribute and it will go and grab certain parameters out of the container rather than having to grab them from the request coming in. Property injection isn't supported and neither is named or key value registration. That's something that a lot of the containers out there do. But one of the things I'm going to be showing is how you can work around this limitation and kind of sort of deal with it as best you can. So as I say, the Microsoft container will integrate with other containers. So I've got a list of the ones that I grabbed from the Microsoft website of the ones that do definitely work with it. Autofac, Drylock. I must admit, apart from Autofac and Unity, I hadn't heard of most of those, but no offense to the authors of them. All of those do things way beyond the .NET container. So things like property injection, injection based on name, child containers, convention-based registration. Some of these things, as I say, we can work around. Other things, what you'd have to do is if your favorite is say Autofac, then what you can do is you can wire Autofac in. So all the registrations that come through your normal the Microsoft container will go to Autofac, but then you've got to go off to Autofac to do the special stuff. So ultimately you end up having to manage two containers and have your code understand how to work with both of them, which does add an overhead. So it's only really if you desperately need those additional features, I would say use those containers. When I first started with .NET Core, I'd been using Autofac and I just thought, well, I'm just going to automatically wire Autofac in. And then after a couple of projects, realized I don't actually need Autofac. The default container does pretty much everything I need it to do. So in ASP.NET Core world, pretty much you do most of your registration of services with the container via the startup class. So you set up your host builder to point to a startup class. In there, you've got configure services where you can do all your registrations. ASP.NET host builder takes care of actually doing the build of the container after that, and then handling how that all gets wired into the ASP.NET pipeline. If you're writing console apps or even unit tests where you're using the service collection and the service provider, you have to do a lot of that work yourself. This tool doesn't really go into the nuts and bolts of that because partly I haven't got time in sort of the hour or so I can do that. But plus there's a lot of sort of grunty stuff about how to manage all that. But there's documentation out there. The key thing is the iService collection interface has a method on it, build service provider, and that's the thing that you're interested in. Once you've registered all your services, then you use that to go and build your container for you. So the basics of the Microsoft container, it supports 3 object lifetimes, so it's pretty much common to all inversion of control containers, as I should say, not dependency injection containers. Singletons, instance is created the first time it's requested and remains for the lifetime of the container. Now, I'm very careful about saying the lifetime of the container there. Depending on your environment, that may also be the lifetime of the application. It may not. Transient, that goes and creates a new instance every time you make a request to the container. Then scoped. Scope sits in the sort of halfway house between the two, in that when a scope starts and a request is made, it's a bit like a transient. It'll go and create a new instance, but it's a bit like a singleton in that rather than disappearing when you finish with it, it will hang around for the length of your scope. So I'll come on to it in a minute, but the typical analogy is in ASP.NET Core, what you do is a scope is created for you when the request comes in. Anything that's registered as scoped will live for the lifetime of that request, going through the whole lifetime of the request, and then disappears when the response goes out the other side. So incompatibility between scopes. So each scope has a specific lifetime. So we've said transient is quite short-lived through to singleton, living for the whole life of the container. interchangeability between those scopes is a bit of a sort of dangerous ground that you could fall into a few holes. So on this diagram, I've sort of indicated that transient is a square, scoped is a hexagon or octagon, looking at it, octagon, and singleton's a circle. The idea behind that is I'm trying to illustrate that you can put a singleton into a hexagon and a square, but you can't go the other way. You can't put a square into a circle or a hexagon. Hopefully all will become clear from the next few parts of filling in the grid. So if you've got a transient lifetime service in your container, then you can pretty much inject anything into it. So if you've got your class constructor that takes, I don't know, anything from one of those three, it'll go in. Scoped, it's a bit longer lived than transient, and therefore you can't really inject a transient into it. But I say can't, there's some caveats around that. So I shall rephrase that saying you shouldn't inject a transient into a scoped. Lastly, singleton is the longest lived, and therefore the other two lifetimes shouldn't be injected into a singleton. Now, I was trying to be careful about how I phrase that then, because there's a general misconception about that you can't insert an incompatible lifetime into another one. So you can't put a transient or scoped into a singleton, for example. The DI container itself won't actually stop you. What it does is if you go and put one of those short-lived lifetimes into a longer lifetime, so transient into scoped, scoped into singleton, then what it will do is it will create what's known as a captured dependency. Now, the diagram I've got to the left is the insect caught in amber. It's a bit like that in that when you put a short-lived dependency into a longer-lived one, it will hang around until the longer-lived one disappears. Now, if you're an ASP.NET Core developer, you may have seen the error that I've just shown below. Invalid operation exception cannot consume scope service from a singleton. So that seems to disagree with what I've just said above. It's saying, no, you definitely can't do it. What's actually going on behind there is you normally only see that error when you're debugging and it's set to the development environment in your environmental variable. What's going on behind the scenes is that the ASP.NET Core host for the web is actually, when it builds the service provider, it passes in an options that has a property called validate scopes. And it says that if the environment is set to is development, it sets validate scope to true, and therefore it'll try and trap any invalid scope lifetime discrepancies. The problem with that is doing that checking is quite intensive. And the recommendation from Microsoft is, whilst you can do that by default in development, don't do it in staging and production because there is a performance hit to it. So the singleton pattern. Singleton's been around for a long, long time. It's one of the 23 well-known Gang of Four patterns from the Design Patterns book. But singleton in container world is slightly different. But the next statement is always true. As Chesney Hawkes used to say, he is the one and only instance of that object in the application. So in context of DI containers, the way you program a singleton differs from the standard model that you used to use for a Gang of Four one. And that's coming up next. So in this chart, I sort of try to pull out the differences between a Gang of Four singleton and a singleton that you use for a DI container. In Gang of Four world, the actual singleton class is itself responsible for the creation and maintenance of that instance. When that singleton dies from there, because it's been declared as a static, it lives for the application. You have to do some work to explicitly design that singleton to handle the creation and exposing that instance. Now, that's usually during construction, assigning to a static property, and then that property gets exposed as a static. Lastly, you need to take care to make sure that all the code in the singleton is thread safe. when you're working with not just the Microsoft DI container, but any DI container, a lot of those rules disappear. In DI world, the container itself is responsible for the lifetime of that class, not that class. So you don't have to have the static constructor, you don't have to have the static property, because ultimately what's happening is the container is doing that work for you. It's saying, I'll go and create it, I'll go and maintain it, I'll go and expose it. Whereas the instance on a static dies with the application, in the container, the instance will die when the container dies. That is not necessarily tied to the application lifetime. Now in ASP.NET Core, yes, the two are sort of quite synonymous. But if you've got a console app, then you may kill off your container long before your application dies. Next one, the container itself, sorry, the container exposes the instance and not the class. So you get the instance through the services. The next is the really interesting one, in that pretty much any class can be registered as a singleton. But you can shoot yourself in the foot with it, because if you haven't designed it properly, you could feel a lot of pain later on. And that's kind of where the next statement is that is common between the two, is that if you're designing a class to be a singleton, you need it to be thread safe. Everyone with me so far? Any questions?
None in the chat?
Anyone chat?
No, all quiet.
Oh, Pete, you've got someone in the waiting room, I see.
Yeah, admitting.
Okay, right. Okay, so a bit of a deep dive into singletons. So, as I say, a singleton needs to be thread safe, because there's no guarantees who will call it and how it will be called. So some general rules for writing thread safe singletons. If you've got collections in there like lists, dictionaries, queues, caches, .NET provides various concurrent collections which do a lot of the hard work about thread safety for you. So I would use one of those and possibly expose it as an I list or an I dictionary, and then marshal it into the concurrent, rather than getting your consumer to worry about using the appropriate methods on the concurrent. If you've got read-only properties, if they are purely set when the instance is created, then you haven't got anything to worry about. If they're read-only for exposing some underlying field which is manipulated by other methods on the class, then you just need to be a bit careful about that, which leads to the next one for read-write properties. And the same goes for underlying fields. All code that touches those, both read and write, should have a lock around them. That way, if anything is trying to access a property that's being written to, it'll wait until the writing is complete. So a bit like in SQL Server, you have transactions and rows can get locked by a transaction. Same kind of principle. Lastly, if the class implements iDisposable, you need to make sure you don't have to do this, but it's kind of a best practice of making sure that iDisposable doesn't leak out to consumers from the container. Reason for that is, if it's a singleton, if one of the consumers calls dispose, then the next consumer comes along, well, the object has been disposed because there's only one and only for the whole lifetime of the container, and your application will start falling over all over the place. So what I tend to do is try and wrap my class, and I'll come to that in a second. Transients. Not really a lot to say on transients. As I've already said, there's new instances created every time they're requested from the container. They're most suited for lightweight stateless objects. So you've just got a simple class that's going to do a small bit of functionality for you, or you're going to sort of fire something to create a DTO that's going to get thrown out to some other's consumer. They can accept both singletons and scoped instances. So because they're the shortest lifetime, they're the ones that can take the ones that have got the longest lifetime. With regards to iDisposable, as long as the container is doing the creation, then the container will look after calling the dispose method on iDisposable. So going more into scope dependencies, as I say, this sort of sits somewhere in the middle ground. They should only really be accessed from a scoped container, and that's coming up in a minute. ASP.NET Core creates a container, a new scope for you on each HTTP request, and that's going to live all the while that the request is flowing through the system and then gets disposed when the response goes out the door. But if you're in a console or even within ASP.NET Core itself, you can go about creating a scope by calling the create scope extension method on iService Provider. That'll go and create a new mini container that is a window into the scoped services, but also it'll go off to the root container and go and get your transients and singletons for you as well. So when you're in ASP.NET Core world, sometimes you'll see on the iApplication something, I can't remember the exact interface name, but there'll be two properties. There's request services and application services. So application services exposes your transient and singletons from the root, whereas request services will expose stuff that's been registered as scoped for you. If you're using middleware in ASP.NET Core, you have to be a bit careful because there's two parts to it. Middleware is effectively created as a singleton when it first fires up. So if you've got anything that relies on the request, which is registered as a scoped, you shouldn't be injecting that via the constructor because you've got a lifetime clash going on there. Instead, what you can do is on the invoke or invoke async methods, when ASP.NET Core calls those, it's able to pass in parameters from the container that you can specify on there. So it's not a fixed interface, it's done through reflection effectively. So you could say, I need the IHTTP context of my request coming in, and you can put that on the invoke method, whereas you couldn't put that on the constructor. Lastly, with a scope, as again, the big caveat, if the container has created the instance for you, it will look over after iDisposable for you as well. Any questions coming through on chat, Pete? No?
Nothing yet?
No? Okay, everyone's good. Okay. Disposables and memory leaks. Now, I've alluded to this on sort of several of the slides so far already. When the container takes care of disposable objects, will depend on several things. It'll only do it if the container itself created the object. A created object must still take care of disposing the things it creates itself. So say you've got a class that implements iDisposable, and then for some reason or other, it's got various instances inside that it's newed up itself rather than relying on the container. The iDisposable implementation on there must take care of dealing with those other objects that it's newed up if they need to be disposed as well. It won't automatically bury through using reflection to find all the things you've done inside your class. Thought does need to be given to the disposal of objects injected in the constructor because, as I say, you don't know as a consumer of the container whether those have been created by the container or some other method has been done within the container, or sorry, within the service registration before it's been registered to go and create it. So, things to consider. Avoid exposing the iDisposable interface to consumers of the container. There's two ways you could do that. You could consider extracting an interface if it's your own code, and then leave off the dispose method off your extracted interface. And then you register against that interface. If it's not your code, so you've got absolutely no control over that code whatsoever, you've got some third-party library, so you can't go and extract an interface, then you can use one of the Gang of Four patterns like facade, adapter, bridge, or proxy to go and hide that underlying code. Effectively, you're creating a wrapper. Now, each of those patterns has slight variations, and you need to pick the one that's most appropriate. But ultimately, you're creating a wrapper that's going to marshal a call and handle the iDisposal of the inner object. Lastly, if the object must take care of disposal itself, consider using a factory pattern. So say as a consumer, I need to go and create an instance of an object through a factory pattern. Well, because the factory is taking care of creating the instance for me, it's almost as if I was creating it myself. And therefore, the container doesn't get involved. It's got no knowledge of that instance that's been created. And therefore, it's up to you as a consumer to call the dispose on anything that's come out of it. As a summary, on the docs site at Microsoft, they go through the various extension methods for registering service. And in the table, it's got automatic object disposal. So the two it highlights there is when you do, say, add singleton, for example, and you just pass in a new instance. That's actually creating the instance before you hand it off to the container to serve up as a service. So if you've newed something up yourself, then you are responsible for disposing of it. That's a bit hard if you've done that during service registration. So it gets a bit tricky. So I try to tend to stay away from that method if I've got anything to do with disposals. The next one is pretty much similar, except I'm just trying to spot the difference. And I can't spot the difference. Ah, right, okay. The first one is treating it as a particular, you're defining the service type, whereas the second one, it's automatically taking the service type as the type of the implementation type. How many times can I say service type and implementation type in one sentence? Right, okay. Now we've got past the whole disposable stuff, and we're on to sort of the common mistakes and patterns that you should be doing with your container. The DI container allows you to register the same service type multiple times. This may be deliberate and it may be inadvertent, but it does come with consequences. So I've got a service type of I am a Beatles song. Here, there, and everywhere are the implementations. I had to get another song title in there somehow, so that was the one I chose. And by the way, there will be a quiz because there's a deliberate error in one of the titles. All the titles should be the names of singles, but one is an album title. So we'll see who's been paying attention to the awful puns I've been doing at the top of the slides. So if you've registered the same service type multiple times, by default, the last registration is the thing that we get served up to consumers of it. So say, for example, you did your registrations and then you called the add MVC. Well, add MVC adds a whole ton of registrations as well. Now, if you've registered one of the ASP.NET classes, for example, and that just so happens to be registered again in a different manner inside add MVC, you'll get the thing that comes out of add MVC rather than the thing that you registered. Similarly, it goes the other way around. If you call add MVC first and then you go and register something, MVC might go a bit funny because it's going to get the thing that you registered rather than what it thought it registered. Another gotcha around that is that if something gets registered multiple times, they may be registered with different lifetime scopes, or sorry, lifetimes, which may be scoped, transient, singleton. You could get yourself into trouble of having something that's been registered initially as a singleton and then as a transient, or vice versa. So just need to be a bit careful with that. As I say, multiple registrations may be deliberate because you want to inject a collection of instances into something. So if you want to do that, if you just ask for the service type in your constructor parameter, then you'll just get the last in that one. However, if you ask for an IEnumerable of that service type, you get the whole collection, everything that got registered against that service type, and you can iterate over it. The order, however, of that enumerable will be the order that it was registered with the container. Everyone with me so far? I don't think there's anything on check. Hold on. If the same type has been registered twice with different lifetimes, does that count all one as two? I think it depends on where you're calling it from. If it's been registered as transient or singleton, I think it's effectively the last in wins. However, if you've got something registered as a scoped and then it's been registered as a transient or singleton, I'm not 100% sure. I'll be honest. It might differ depending if you're coming from the scoped container or from the root container. So I don't have a straight answer on that. It's typical developer answer of it depends. I don't have an out-and-out answer on that. It's one to go and look up. Okay, any other questions coming through on chat? No. Okay, so if you're worried about accidentally registering things multiple times, how do you get around it? This is a particular concern if you're writing a library that you're going to share with other people, either within your organization or externally as a NuGet package, because the last thing you want to do is cause mayhem with other people's code. So there's two ways you can go about it with the extension methods. There's a try-add extension where you can say, I'm going to register against a particular service type. So in the example, Scott, Charlene, and Bouncer the dog have all got broken hearts. They're all been registered with broken hearts. Then I've registered them all over again. So with try-add, it's the opposite of the consumer side. It's the first in wins. That's the thing that's going to stick. All the others will be ignored because they'll say, I've already registered an I broken heart. I don't care about you. And I feel sorry for Bouncer the dog because his broken heart, there's no consideration of him whatsoever. The poor dog is suffering. Well, not that much. He's got a party hat on, so he can't be suffering that much. The alternative way is to use try-add enumerable extension. What this does is instead of just looking at the service type, it looks at the implementation type or the implementation function that's registered as well. So taking the same example over again, I've registered the 3 broken hearts and then I've registered them over again. This time, because I've used try-add enumerable, the first 3 will stick as opposed to the first 1, and the last 3 get ignored because it's comparing both the service type and the implementation type as well. Okay. So we're talking about deliberate multiple registrations of the same interface. Why would you possibly want to do that? You may want to register multiple implementations because you're doing something like a gang of 4 strategy pattern or visitor pattern, where you've got a consumer that says, I want to do multiple operations on something and I'm going to get all the things I need to do out of the container. Example of that might be validation rules. So you might have 15 validation rules that rather than sticking them all into a class and hard coded, you can implement them all as an I validation rule, register them all as I validation rule. Then your consumer that wants to run the validation rules can say, I want an enumerable of I validation rules, and then can just apply those validation rules to a particular object. The problem with that is as far as a consumer you are concerned, you just know you've got a collection of I validation rules. You don't know what the differences are. And in some cases, you may need to be able to filter them or do something based on the actual implementation. The whole point of inversion of control and dependency injection is that you want to try and hide the implementations so that, coming back to things like solid principles and unit testing, you may want to swap out an implementation later on. So the consumer of the container shouldn't really know that much about the concrete instance. There's a couple of ways you can get around that. You could have another interface and each instance works through, as well as implementing the common interface of, say, as I've got here, I am a lady, then you could have I'm a Matt Lucas lady, I'm a David Williams lady, some kind of differentiator that may not necessarily allude to the concrete type. Another way you could do it is to have a custom attribute. So that way you may, for example, have a custom attribute that provides the sort order of how you want to apply those enumerable rules. So that way you can take the order control out of the container and use the actual implementations or some other mechanism to control the ordering, so that as a consumer you can then say, go and get the custom attributes, sort by those custom attributes, and now apply my collection. Okay. Flipping it on its head, we've said that one interface may have many implementations. One class may have many interfaces. If you're using solid principles and using interface segregation principle, you may have one class that has 10, 15 interfaces, so that it can apply each finely grained interface. And as a consumer of that class, you can take you can just say, I just want this finely grained bit of it that has 1 or 2 properties, rather than having to worry about 20, 30 properties if they were all implemented in one massive interface. In the registry, if you register that class in the usual manner, then if you try and register it against, say, 5 different interfaces, saying add singleton, add transient, add scope, for example, you will actually end up with 5 different instances. Now, that's not the end of the world if it's a transient, or potentially not the end of the world if it's a scoped. If it's a singleton, that can potentially be a problem, especially if you're relying on that singleton to do some marshalling between all the different consumers, because then you've got 2 singletons and it's not really a singleton anymore. You've got different faces of multiple singletons. 2 ways you can approach that. My preferred route is to take all the interfaces and create another interface that's an aggregation of that interface. So, for example, I've got at the bottom I interface 1, 2, and 3, and then I have my interface aggregate that implements, inherits, depending on how you like to use the technology, of those 3 interfaces. That way, I can, when I come to register my concrete, instead of having to register the concrete, I can then register that aggregate interface. From there, to avoid creating multiple instances, when I register interfaces 1, 2, and 3, what I do is I actually go off to the service provider again and say, go and get me that my interface aggregate and give me that single implementation of it that I've just already registered. That way, when you, as a consumer, you can either ask for the aggregate interfaces 1, 2, and 3, you will still get the same object back. So there's something just come up on chat. Surely with that code, the first man wins applies.
It might have been from the previous slide.
Right. Sorry.
I didn't have a chance to interrupt you. You're in your flow.
Sorry. Do you want me to go? Shall I go back to the previous slide?
Yeah. As you're there,
okay.
We've interrupted you.
You are absolutely right. I copied and pasted triad singleton rather than add singleton. So you're absolutely right. First in would have won on that. That should have said add singleton. And you can tell that this is a work in progress. There was bits of it were written today.
That's good. That's
cool.
Good that you know exactly what that was. And every time you say triad singleton, I'm thinking of some strange gang that are going to come and get.
A triad singleton. The member of the triad who just cannot get a partner. He is the triad singleton.
That one.
Right. Okay. Okay. Cool. Sorry about that. I'll have to sack the QA team on that. Right. Any questions
that's
on
us? We are the QA team.
You are my QA team for the this is alpha release 1. So if there's no questions on that slide, I'll move forward. Open generics. So obviously you've got generics, lists, dictionaries. So you have a list of T, queue of T, etc., etc., etc. Now, normally you wouldn't actually register lists as such within your container, generic ones. 2 approaches you can take with it. you can effectively make a closed generic. So say you've got list of string, then what you could do is have a class that inherits list of string, and that's the thing that you register. But that's a whole load of additional code. And say you want this, that 5 different ones of those, then you've got to go and create 5 different classes and then potentially have 5 different interfaces. It all snowballs into a whole load of code just to get around some limitations. What you can do though is, what the example shows iList. Say you've got your own class that is an open generic. So you've got something that can take a type parameter and it will do some function regardless of type. So in the example that I had prepared, what it would do is it would take and then spit out the string versions of their names for you. What you can do is register an open generic. So in this example, I've got iList. I've got my brackets, but with no T or TR or what have you. I don't say what it is. So the consumer can then say, I want a list of strings. I want a list of Wibble. I want a list of Bob. As I say, you wouldn't necessarily do it with the generics that come out the box, but if you write your own generics, that's a way of opening up so that your consumers control what the generic type is. To do that though, you can't use a lot of the regular extension methods because they use generics themselves, because you can't use an open generic as a generic type. So you have to use the non-generic of add singleton and pass in the type of the service and the type of the implementing class. So that's rather a long, garbled way of trying to explain that. If you Google that, I'm sure that someone's probably written a blog that can explain it far more eloquently than I just tried to. This is where the code example would have come in much more handy, because I had a code sample ready, but I'm looking at the clock and it's 20 to 9, so I will plow on. Factory and builder patterns. Again, these are sort of part of the gang of 4. Sometimes it's not possible to completely rely on the container to do all the work of creating the instance for you. There may be several reasons. It might be that the parameters for the constructor on your implementation just cannot be resolved from a container. Typical example of that would be integers, doubles, strings, all the, think of the right word, all the key types that come out of the box at a low level. I want to say native, but I know that's not the right term for it. You can't register, the container just will not let you register those, because what's the point? Every time I want a string, I want the same string over and over again. Well, no, not really. So there's a bit of a problem. A classic one, but a bit of a code smell, is if you've got a Boolean in your constructor. I hate Booleans in constructors. If you're going to do that, please use an enumerable of yes, no, or true, false, or this, that, or something, because Boolean doesn't really say a lot in a constructor. While some of the parameters can be created, they may need configuration before being consumed by the constructor. Now, right back at the start, I said about property injection is supported by some of the containers. That possibly may be where a property injection may be required. So I've been doing some work recently trying to write a shim over the ASP.NET membership provider back from ASP.NET 2. And that by default doesn't have a constructor. It's just got a whole load of properties, and then you call initialize. Well, you can't, I mean, that doesn't exist in .NET Core World anyway, but say it did, you just can't do that with the container. What you can do is you can write a factory for it, and I'll go into the mechanics in a minute. It may be that you've got a particular class that you want to control the instantiation of, because you want to be in control of disposing of it. Now, as I said, in many situations, if the container is in charge of control of creating the instance, it will also be in control of doing the disposal. And as I say, the last scenario is property injection. So how do we get around it with factories and builders? So the factory pattern, what we do is we'll rely on the container to populate common parameters via a constructor for us. So we'll write a factory class that will take I wibble, I say hello, stuff like that, stuff that's common across the container. But that leaves us with how do we deal with the parameters that are controlled by runtime that aren't in the container. So on our factory class, what we'll do is we'll have a create method that takes those runtime parameters. It will then take both the objects that have been created out of the container. It can then instantiate the class that you actually want to generate, also passing in the other parameters. Now, this sounds like an awful lot of work, and also you're not taking full advantage of the container, because inside your factory, you're having to say new against the instance you want, but I'll come on to how we can get around that in a minute. Lastly, the object that gets created, if it implements iDisposable, it's up to the consumer of the factory create method to dispose of it. The alternative to the factory pattern is the gang of four builder pattern. Now, those who are familiar with ASP.NET Core, you're kind of effectively using the builder pattern when you're building the host, because you have a host builder and then eventually you say build and run. That's the builder pattern at work there. What you can do is, if you've got a particular class where you need to go and instantiate it, and then need to apply various methods or properties to it, you can use the builder to do that for you. So what you'll do is the basic empty class, you'll register with the container, you'll register the builder, and in the constructor to the builder, you'll take in the class that ultimately you want to spit out at the end of it, being consumed from the container. Once you've got that, you can expose the builder. The consumer can do all the builds and then call build at the end of it. And it's that build process that will go and return the class that's got all the properties on there. So that way you can encapsulate it all within the builder. It may be that the builder has to actually go and build another object, taking everything that from the build properties or methods that you've called. So in the example of host builder in ASP.NET Core, you're using the builder pattern to apply various properties, methods, extension methods, but ultimately you call build to generate an iHost, and it's the iHost that's consumed, not the builder. But that's an awful lot of work, and you're having to marshal what's coming from the container and what's coming from parameters. In .NET Core, there's this class, the Activator Utilities class, and it's really helpful grunt work for you. What you can do is, using that class, you can pass it an iService provider, which you've taken in the constructor to your factory or your builder. You could, in theory, use get required service to do that, but then you've got to know about all the services. What this will do is it will take the iService provider, and you can pass it just the object array of the parameters you've taken in at runtime, and then it will do all the hard work of saying, okay, what comes from the service provider and what's come from the parameter array that you've passed me, and it'll do all that wiring up for you. Sometimes it gets itself into a bit of trouble because you may have a quite complicated constructor parameter list. You can give it a bit of help with the Activator Utilities constructor attribute. If you apply that to the constructor, it just gives it a little bit of help. And there's documentation on the URL I've got at the bottom of that slide. Another pattern that we can use is using delegates instead of interfaces. Now, with the container, the service type, yes, we go and register interfaces. Sometimes we register concretes, but there's nothing to stop you registering a custom delegate because it's a first-class citizen type. What you can't do is you can't register the anonymous functions, so funct, funct2, funct t1, t2, etc., because those don't really work in a container world. But the custom delegate type, where you go and create a delegate with a name and define a function or action signature to it, you can register one of those. Now that opens up an awful lot of opportunities, and I would dearly love to about it. But the key takeaways from it, as far as I'm concerned, is there's two things you can do. It opens up the possibility of having named or keyed registrations. And it also gives you a way of hiding static functions by making them injectable. I've got a URL there of the blog post I did with it, but that came off the back of another blog post I did, which was injecting by name or key. Now, this is considered a bit of an anti-pattern, so why would you do it? So how I started investigating this was I had a project where I was consuming data, and depending on a particular value that came in on that data, which changed per row, differed the implementation of an interface I wanted to apply to transforming that particular row. Now, what I could have done was, as I said earlier, I could have done different interfaces for the different implementations and then had a lookup dictionary that said, well, if this bit of data called Bob, then call the iBob interface, and so on, so on, so on. But it felt clunky, and it's putting responsibility on the class that was reading the data to do all that lookups via the iService provider, which is an anti-pattern in itself because it's a service locator. But what you can do is when you can manually register a delegate that takes a name as its input and hands back an instance of a particular interface. So you're moving it back into the container where it kind of belongs. Now you can take the approach of doing some hard coding inside your service registrations and says, if I get M in, give me an implementation that does, I don't know, mammals. If I get a B in, give me an implementation that deals with birds, etc., etc. When I implemented it, what I did was I actually registered a dictionary as a singleton and then used a lookup in that dictionary to say, in the dictionary, here's all the strings that come in. And what I got back was another delegate that passed me the appropriate service provider call to go and get the instance that was appropriate for that. Very hard to explain that just on a PowerPoint slide. If you're interested, I've got the URL link to my name dependencies part 2. If none of that made any sense whatsoever, go and look at part 1 that tries to explain a bit more eloquently than I could verbally.
Steve?
Yeah?
Apologies for the pronunciation of your name, but Mahela Radu is saying that you're missing a not.
On the
that should say,
side.
yeah, Microsoft DI container does not support this, but other containers do.
Thank you.
Apologies for pronunciation.
Okay. Brilliant. Thank you. Okay. So, decorator classes. So decorator class is yet another Gang of 4 pattern. And what that does is it extends or alters the functionality of objects by effectively creating a wrapper and then intercepting calls on the way in and intercepting calls on the way out. I like this pattern because if you've got a third-party library class that doesn't support logging, you can implement logging yourself. So what you can do is if you implement the same interface, if it's got an interface, then say you've got a method, get some data, then you can intercept that method and say, on the way in, I'm going to log that I received a request to go and get the data. I'll go and get the data using the underlying class. Now on the way out, I'll log that says, yes, I successfully got the data, or the underlying class threw an error, and I'll log the exception that came out, and I will then raise that error, bubble that error back up again. So I really like the decorator pattern. Coming towards the end, a few anti-patterns and other bad boy behaviors that to do with containers. It's not always possible to avoid it, but try to avoid injecting the iService provider. Originally, service locators were flavor of the month before inversion of control containers really took a hold, in that you had some method that would go and look stuff up for you and create instances for you. But that relied on the consumer saying, I'm going to go and call that service locator to go and get that instance for me. With modern containers, that's taken away because they're built into the pipeline. So when you go and get a class, it knows how to go and get other things being injected into it through the container just by saying in your constructor, I want one of these in there. Try to avoid that. Sometimes you can't avoid it, but some do try to avoid it. Avoid having too many dependencies in the constructor. This is more about solid principles and the single responsibility pattern, in that if you've got 20 different things being injected into your class at constructor time, does it really need all those 20? Are you doing some kind of orchestration in there that could actually be refactored out to some other class and just as a single responsibility? So it's more of a solid thing than to do with the container itself, but it is a code smell. The last one, constructors should be idempotent to outside concerns. What am I trying to say there? In the old gang of four singleton pattern, you may have something in your constructor that goes and fires up a connection to a database and does something. That's fine in the gang of four pattern because you are in complete control of that instantiation and the constructor work that goes on. In container world, you're not in control of that. The container is in control of that. What could be worse is, say you've intended that class to be used as a singleton and someone goes and fires it up as a registered transient or a scoped. That means it's being fired up over and over again. If that work you're doing in your constructor is going and doing something quite drastic to your database, that could be a major problem for you. If you really must do that, if you've got a singleton, then what you can do is use the lazy construct inside .NET Core. And I think it was there in Framework as well, because that effectively does your lazy instantiation for you. So it'll be created the first time you ask for it. And then next time someone else comes along for a value out of the lazy structure, it will serve up the thing it's already constructed once. But really, everything in the constructor of your class should be just to do with your class and not talking to the outside world. By all means, have methods that talk to the outside world, but you really shouldn't be doing that in your constructor. A couple of other ones. Avoid using static methods and properties on the classes being injected. Now, if you're doing solid correctly, and making everything unit testable, you're not actually injecting concrete types. You're only injecting interfaces or possibly delegates. So this is a moot point on those scenarios. Though, of course, with C#8, you can actually have static methods and properties on interfaces, which makes things a bit weird. But ultimately, what you shouldn't be doing is asking for a concrete type of something and then calling for static methods, because yes, you can do it. Under circumstances, yes, you may need to do it. But generally, it's a code smell because it makes your code really hard to unit test. Unless that static method is coming from a third-party library that's been absolutely tested to death, then you can guarantee that what goes in will always come out. I would stay away from them. Lastly, don't rely on static classes in your own code. Now, this is nothing really to do with containers per se, but it's all tied in with containers being used to make your stuff unit testable and the solid principles. if you're using, and my hobby horse is system date time now, you've got absolutely no control over that because it changes every single millisecond. How on earth do you unit test stuff if you've got date time now in there? So what I try to do is, going back where we're saying about factories and the delegates, is I try and create a class that's effectively a wrapper over date time now. And either, if I'm using lots of properties of date time now, expose it via an interface, or if I'm just using the now or now UTC, is have a delegate that says get current date or get current date time, something like that, and let the delegate worry about talking to date time now. All your consumer is worried about is the delegate coming in or the interface coming in, which means the delegate and the interface can be unit tested, and suddenly your code goes from being really hard to unit test because it's talking to something like date time now to actually really quite easy to unit test. And that's my little rant over. A couple of useful tools out there. If you've got a really massive project, so you've got hundreds of services you want to register, that can become quite laborious. There are these libraries. Scruter is one, and John Smith, who did the Entity Framework Core in Action book, has written one as well. And a couple of guys I know have also written ones, but they were mainly for their own kind of use. What these will do is you can point at an assembly and say, go and everything that's a class in that assembly that implements interfaces is go and automatically register those classes and those interfaces for me. Now, that depending on the library, there's different levels of control about how do you know what to register as singletons, how do you know what to register as transients, scoped, etc. Because there's a bit of sort of science to it. You can't just say, just go and register everything as a singleton. That's dangerous territory. But if it fits and you've got the need for that, that can probably save you a lot of work. Personally, I'm a control freak. I like to do all this stuff myself so that when something goes wrong, I can find the line that's gone wrong. Whereas if you go into sort of the search libraries, you don't necessarily, because you're abstracted away from it a bit by the control that you say, go and register types in this kind of domain as singletons and these as scope. Well, what if something isn't quite matching what you expect it to be? It's a real hard thing to try and work out what's gone wrong. So it's there if you want it. It's great. Scruter, though does have a really useful function of being able to handle your decorator injection for you. So if you've got various decorators, then that will handle replacing the original object with a decorator object. So that's a really handy thing to have for that. Pretty much coming up to the end, the last thing to think about is with all these services being fired up, you've got two things to consider. Does the class itself take its time to fire up during its construction? But also, even if it doesn't, the first time it's being called, you've got the JIT compiler kicking in. So there is a bit of a lag time the very first time some of these things coming out of the container are constructed. What you can do is when your application starts up, is go and instantiate, go and have something that goes to the container and says, go and tell me all the services that have been registered, and go and fire up an instance of them. Now, this comes back to what I was saying about don't have things like go and firing up database stuff in your constructors because you don't know how it's going to be used. And something like warming stuff up may go and do a bit of damage. But there's a really good blog post by Andrew Locke, who wrote the ASP.NET Core in Action book about how he approached it. But in essence, what you do is you fire up a background task that once all the registration is complete and you've got your host built, go and fire up this background task to go and start doing those asynchronously to your application starting. So you're not holding up your application starting, you're just warming stuff up in the background. If someone comes along and requests one of those things in the meantime, well, it's no big deal. So we're pretty much coming to the end now. So I've whittled on for about an hour or so about things, the gang of four patterns. So I've pulled out some things that just to have in the back of your mind when you're doing stuff with the containers. Singleton pattern, we've talked about the differences between the gang of four pattern and using singletons in a container. Builder and factory are great for handling those situations where the container can't quite do everything you need to go and construct a class instance for you. With a bit of help from them, you can get the fact, and then registering your factory or builder with the container, you can save a lot of work from the consumer having to new stuff up. You can get the container to do a lot of the work for you. Structural patterns. I've touched on briefly about using wrappers. 4 different wrappers: adapter, bridge, facade, and proxy. All slightly different. So adapter is when you're not in control of 2 incompatible interfaces, whereas bridge, you are in control of the implementations behind those interfaces. Facade is simplifying stuff. Proxy is passing it on. And then lastly, my favorite, decorator. Bit like proxy, but allows you to add some functionality by intercepting calls to it. And that's it. So what's that, about an hour and 5 minutes, something like that. I've whittled on. Thank you for listening to me. For those of you who still, hopefully there are a few people still in the room. If you're interested in stuff I've been talking about, I tweet quite a lot and blog at Steve Talks Code. With the whole lockdown at the moment, I'm probably going to start blogging quite a bit more because I've been a bit remiss over the last year in blogging. So I'll watch this space on that. I touched on just now, Andrew Locke's got a brilliant blog site. I find that a lot of this information, when I first started getting into it, I'd say a good 50% of it, when I looked stuff up, I ended up on his blog site. He's got the brilliant ASP.NET Core in Action book as well. Highly recommend it. Some of the stuff that I touched on about understanding the basic differences of scope lifetimes, what the container does and doesn't do, that you can find on the fundamentals page on the Microsoft Docs site. Microsoft Docs is really good now, and I highly recommend going to that. Lastly, if you want a much broader overview of dependency injection, Mark Seaman's book, Dependency Injection, Principle, Practice and Patterns on Manning, is a really good read. It starts off by the fundamentals of dependency injection, regardless of which container you're using. And then it goes through all the common containers. So Unity, Ninject, the Microsoft one, AutoFac, and I think there's another one by his co-author. I can't remember what it's. I think it's Simple Injector possibly. And it goes through a chapter of each of those and how they apply to the overall DI principles and what the things they're good at and what their shortcomings are. So if you are tempted to go and use one of those other containers that you can hook into the Microsoft one, really good read. With that, that's me. And lastly, happy Star Wars Day. Thank you.
Thank you very much. There's a few bits and bobs in the chat, but if I unmute everybody, then if there's something that's not been answered, then do shout out.
Okay, I'm curious about Mark Oliver's one. Violates Nicholas' 4th law of IOC. That's one for me to go and have a look at. Which point was that on, Mark?
It was to do with the class you're instantiating shouldn't do anything important in the constructor.
Right.
Yeah, there's an interesting blog post that sets out these laws of IOC.
Okay.
And that's the 4th law, and it's really interesting. It does make a big difference.
I have just cut and pasted that into Notepad so I can go and look at that later. I thought you were saying something I'd written violated it.
No, it's backed up by that law.
Oh, fabulous. Brilliant. Yeah. The slides, it's very much a work in progress at the moment, so watch this space. Over the coming weeks, I'll type them up and do any corrections, and then what I'll do is I've got a whole load of code samples that I wrote for this, and as I say, would have been here till midnight if I'd have gone through the code samples. So what I'll try and do is inject some of the code samples into the slides, and then I'll publish the slides once that's done. So if you keep an eye out on my Twitter handle, so I'll just go back, Steve Talks Code. When they're published, I'll get them out there. Okay. Any other questions? Environmental variables is another one for built-in class. Best dealt with through DI. Okay.
No, just put this one in.
I'm just reading your one, Stephen. Environmental variables is another one for the built-in class.
Another example.
Yeah.
You used Datetime Now, which is one that I constantly get our developers running, but I also see them do startup code where they set a bunch of environment variables rather than just wrapping it in an interface.
Yeah. So yeah, but basically anything that's outside of control, I want wrapped in an interface usually. Okay. So what about the registration approach has since removed it? So that was you again, Mark. So you had problems with one of the automatic registrations. Not sure Mark's there. Can you see Pete? This
one. Yeah, he's there. Yeah.
Yeah.
I think he's muted.
Ah, right. Okay.
No. This is
now. Mark decorator pattern. Yeah. Okay. Questions, slides. Thank you. So thank you, Carolina.
Hold on.
Some debate at work recently. Suppose that you were developing a library class that heavily uses DI. How do you represent to potential users the library standard expecting wiring? Interesting one. I don't have an answer off the top of my head. I'll be honest. I think that's certainly where the try methods can help, but it doesn't actually express what you've registered.
What I've decided, I think she has actually killed her husband and fed him to the tigers. I do believe it.
Sorry, I didn't quite catch that.
I think it was just background noise.
Oh, right. Sorry. Okay. Mark can't unmute himself. Okay. Okay. Mark, are you there now?
He's unmuted.
Can you hear me?
There we are. Yeah, we can hear you.
Yeah. So Mark, you said you had the automatic registrations and then you took them out again.
Yeah. Not knowing what was registered and what's not was a real downside for us. It also meant that we were picking up, kind of, you've alluded to it, we were picking up registrations that overrode other registrations, and it just became a real headache.
Yeah.
Knowing what's registered when and where, although your registrations can be a few hundred lines long in one place, but it is just one thing. It was a big improvement taking out the auto registration stuff.
Yeah, I mean, I do like Scrooter for managing the decorators, because what you can do is you can have a class already registered and then said, actually, I want to decorate that class with this. And it'll take care of handling the old registration and replacing it for you. So it's good on that front. But the whole automatic registrations, for the very reason you've just said, is I'm a complete control freak. I don't like this idea of all this stuff going on in the background and I don't know what's going on. Right. Any other questions coming through? I think that might be it now, isn't it, Pete?
I think so. It looks like it. Yeah, I think that's it. Well, thank you very much, Steve.
Okay, my pleasure. Thank you for having me.
Thanks, Matt. Well.
Sorry, I didn't actually come up to Nottingham, but I think this was the next best thing we could do.
Yeah, no, it's perfect. Yeah, thank you. Really appreciate it. So yeah, thank you very much for everybody who came along as well. Really appreciate you coming along. It's a little bit different running these things online, but it does make a lot of other things easier. This has been broadcast out onto YouTube, so once it's finished broadcasting, you'll be able to catch up if you need to go back through any parts of it. So that's one of the benefits of running this online as well. As I say, on the, what was it, the 25th? Yeah, the 25th. So in 3 weeks' time, in fact, we'll have David Whitney and brain fade. Who else have we got? John Staveley, speaking. So that'll be a good meetup too. So 2 meetups in May. Other than that, keep in touch. There will be a draw over the next coming days or so for anybody that's tweeted on the hashtag .NETNots. And you can win one of the JetBrains products for a year. So That's very good of those to sponsor too. But yeah, other than that, thank you again to our speakers.
Pete, by the way, general question out there, if everyone's off mute, did anyone spot the title that was an album title instead of a single title? No. So it was Eye to the Telescope.
Pet Shop Boys.
No, it was Katie Tunstall's Eye to the Telescope.
Okay.
So that was an album title rather than, but it was the only thing, out of all the things I could search for, it was the only thing that mentioned scope in the title. So it was a bit tenuous. I mean, all of them were very tenuous, but that was a really tenuous one.
Fair enough. I liked all those different titles. They were good. Good. All right.
Right.
Well,
okay. Right.
Thanks
everyone.
everybody for coming, and we'll catch you in a few weeks'
Thank
time.
you.
Okay. Cheers
Thank
then.
you,
Right. Thanks then.
Thanks
Bye.
very much.
Bye. Bye.